All right, week 5, kinetics. In this week, I've got some videos for you to watch on force platform technology. Some of them sort of run on a little bit long and me talking in the lab, and some are actually from Volt website. So let me go through what we have for this week. So kinetics, I'll just put the date down here that you watched the videos. We're gonna put the watch me first here. That's this video. I'll put the link there once I have it. And then I've got these videos right here. Force platform anatomy. I just go in the lab and I talk about a couple of the force platforms that we have, explain the setup, explain how the force platforms are connected to an amplifier, junction box, and then ultimately the A to D board. So I sort of give a big overview of. We'll probably do that in the lab as well. So you get sort of a double dose of that. Then I go through a portable force platform, and I find this useful because this is a low-cost force platform and sort of gives a little more sense of what the sensors are in the force platform and what they're doing. And then 2 short videos from Volt. The second one is about the counter movement jump as measured by Volt. And then I added this one right here, which is more of a lecture I've done on looking at the ground reaction force during a counter movement jump. I don't have the landing here. I have another landing video, but I just put the counter movement jump in, and you'll see that counter movement jump ground reaction force in this 3-minute video, and you'll see it when we're in the lab doing the movement. Well, it's important to understand what the force tracing is telling us and what it's not telling us, and so that's what this video is about. It's all about linking kinetics back to kinematics. So Newton's second law, all the forces acting on an object added up together equals the product of mass times acceleration of the center of mass. Mass being a measure of inertia, and object's resistance to change motion, kilograms are the units. So F equals ma. F, kinetics, equals ma, a being the kinematics. Now, acceleration is a little bit of a tricky term to get down correctly. It's often confusing, and acceleration is not overly hard to understand, define, and even remember equation and units for, but it is a little bit different than thinking of velocity. So acceleration is rate of change of velocity, delta v over delta t. Units are any units of velocity over any units of time, so meters per second, which we do the algebra, we get meters per second squared. And an acceleration that I'm sure you're all familiar with is the acceleration due to the force of gravity. That acceleration is negative 9.8 meters per second squared. What that tells us is the force of gravity is acting on an object. If that was the only force acting on the object, and I drop the object would accelerate at a rate of negative 9.8 meters per second squared. Acceleration is just telling us how fast velocity is changing. All right. And if I drop the object would start with 0 velocity, and after 1 second, it would be going negative 9.8 meters per second, because the acceleration is negative 9.8 meters per second every second. So after 1 second of being in flight, it'd be going negative 9.8 meters per second. The negative sign of the velocity indicates that the object is moving downwards. If after 2 seconds it was in the air, then it would be another 9.8 meters per second. So negative 19.6 meters per second after 2 seconds. And then it would continue to accelerate at negative 9.8 meters per second every second. So that we would say the object's speeding up while moving downwards for that example. Now, if I did the flip of that, and I took the object and threw it up in the air, what would be happening? It would leave my hand, and it would have some velocity initially. Then what would happen? It would slow down until it reached the top of its flight, and then it would start coming back down. At what rate is the velocity slowing down? It's slowing down at a rate of negative 9.8 meters per second every second. So let's say that after the object leaves my hand, it's going 19.6 meters per second, positive, meaning that's going upwards. If it was in the air for 1 second and gravity is the only force acting on the object, how fast would it be going? It would be going 9.8 meters per second. Acceleration is negative 9.8 meters per second every second. So it'd be slowing down at a rate of 9.8 meters per second every second. After 1 second, it's going 9.8 meters per second, positive. Why positive? Because it's still moving upwards. So the direction of acceleration does not tell us direction of motion. That's where things get a little confusing. Direction of acceleration simply tells us the direction of the slope of the velocity versus time plot. I've got some other videos on that. So either the object is speeding up, moving downwards, or it's slowing down, moving upwards, or some combination of. And so that is an easy way to link kinetics to kinematics. Now, when we're looking at a ground reaction force, in essence, we're looking at acceleration. So that's where it can get a little confusing when we're trying to interpret ground reaction forces, and we start looking at a force and we say, oh, that must be downward movement, or that must be upward movement, or whichever way direction we're dealing with. And we've got to be careful, because the direction of acceleration does not tell us the direction of movement. Likewise, direction of force doesn't tell us the direction of movement, unless we know other pieces of the story. I can have an object, I can have a car rolling towards me, and I can push on the car in that direction, but the car still moves that way. Why? Because maybe I'm causing the car to slow down while moving in a particular direction. But my force being applied is in a different direction. Okay, so we're going to try to get our hands or minds wrapped around ground reaction forces and using force platforms to measure the force of the ground pushing on the person. All right, a little short week, but hopefully these are helpful. Okay, thanks everybody.